Hi, my name is Mathias Sønderskov Schaltz. I'm the Computational Lead at LINK Arkitektur, and here's my NORDFY talk.
Hi, welcome to another NORDFY Talks. I'm here today with Mathias Sønderskov. He is the Computational Design Lead at LINK IO. Hi Mathias, welcome.
Hi, Thiago. Thank you.
Matthias, I would like to start to ask who Mathias Sønderskov is and what is your role at LINK Arkitektur?
Yeah, I'm the Computational Design Lead, as you just said. For me, that involves setting directions for our development work in our computational department we call LINK IO. LINK IO is not actually a real department, it's more like a network. It's a philosophy, and it's sort of intertwining all of our offices in LINK. We have a lot of offices all around in Scandinavia. We are almost 500 employees, and in the IO department we're around 10 people working with development, digital development, computational design, parametric design. We also have an influencers network in the organization, which means that if there's a LINK office that doesn't have a real IO person, we have some ambassadors around in the office that can sort of help pushing our services into the projects and know who to call and so on. But in the core IO, we are around 10 people with half-time looking at digital workflows and half-time consultancy works on projects.
And when is this LINK IO? So you said it's not a department, it's like a research and innovation unit?
Yeah.
Okay. And when has this started?
It was about 3-4 years ago. I joined 2 years ago. Before that, I was computational design at LINK Larsen for 7 years. What sort of lured me over to LINK was that they had some previous employees that left, and there was a chance to sort of build something up, like a reboot of the IO department. Yeah. And in the LINK organization, I can see that it's very highly prioritized. LINK Arkitektur is owned by Multiconsult in Norway, with I think several thousand employees also, and they are also getting their eyes up for computational design now. So we in LINK IO are sort of also pushing a little bit to the big mothership in Multiconsult. Yeah.
So how you said that you have multiple offices and 500 people.
Yeah.
All in Scandinavia.
All in Scandinavia. Only Scandinavian projects.
Only Scandinavian projects.
And we are working mainly with residential development and hospital buildings, healthcare buildings. So we're doing a lot of these big super hospitals, and we have experts who know all about these logistics on, elevators and hospital beds and all of this stuff.
Yeah. What would you consider to be like really exciting work? You just mentioned that you have had the opportunity to reboot LINK IO, and coming from a company like Henning Larsen, where you've been for so many years. What is exciting about the work you do and the projects you participate or the tasks you do?
What excites me most is actually that there's still people in every organization, but I feel it a lot in LINK in the start, that they get so impressed when you show what you can do with computational design. And what is really cool about working in our IO network is that you get to do some non-billable development work, and then you can actually bill fairly small amount of time on a project, and your partners on the project will be like, wow, how could you do it in relatively short amount of time, right? So it's sort of the development work is very much funded, not on the projects, but our organization, yeah, which allows us to do a lot of impact on those projects we're then involved in a relatively short time. Yeah. So we're both sort of pushing in the long end, but we also kind of firefighters. When you only have 2 more hours before deadline, maybe we have some code or workflow that we can reuse to help you fix this thing, because otherwise we will be out of time.
What would you consider to be the key competences that you brought to to LINK that helps also LINK differentiate or grow? You're saying that contributes to deliver work maybe in a higher, a faster way. What are your core competencies?
I mean, my profile comes from, I'm a hybrid engineer architect, very interested in all of the technical building performance, daylight and so on, but still with, let's say, a creative mindset. When I joined back at Henning Larsen, I didn't know anything about daylight and stuff. Not daylight wasn't really taught at education, for instance. And I had a good mentor there that taught me about everything about daylight. And then I found myself in a department where you have PhD students and specialists in all different fields. And me from school being trained a little bit of for instance, Grasshopper, but also having conservative professor who said, you can't do real projects with this. It's nice for a pavilion or something like that. Put it away and focus on the real craftsmanship of architecture. And when I joined that Henning Larsen, I found out that parametric design is the glue that binds together all of the disciplines. That's, let's say, not necessarily the shared model, but it's the translator. And it's the only way you can sort of unfold the design possibilities within the technical constraints you have. So I found myself suddenly, even as an intern, sort of becoming a glue between a lot of experts and compiling that into actual design. Working on a lot of projects in all phases, from volume studies to detail design in facades and so on. I have experience with most of the design process, and coming to LINK, given the opportunity to sort of digitalize all of that knowledge, allows us to sort of make a toolbox with all of the stuff I've been through on projects, but also all of the theory we have and so on, put that into a toolbox that then every architect in the company can use. And for me, that's sort of, it's a mix of everything, and I think maybe the most important ingredient in that mix is actually communication about it. Because it doesn't matter if you know everything about every discipline, if you can communicate it to the stakeholders, to the designers, and so on. And I believe that communication is the only way you can sort of change an organization from the inside.
Yeah. It's interesting. You were talking about. I was about to ask you about this having this interdisciplinary compute, as you call it, on your website as an in-house research and innovation unit. How would that benefit LINK? But you already touched upon it, and you just said something about creating a toolbox where different designers can tap into and utilize on projects. So maybe my next question would be more, who are those designers? Who's actually utilizing the tools? Are you more linked to a specific sector, like you talked about healthcare, or are you an extended arm of a competition, early stage designers? Where does IO contribute to the most, or how integrated it is at scale?
It stands on sort of, I would say, almost like three legs. One is pure consultancy directly to the client. We can offer a service. Sometimes it's a technical service, like a wind simulation report or daylight report. And sometimes it's we call it the building sketcher, an early phase program we made, but it's a service we sell when we use that on your project. That's the one leg. The other one is sort of having, let's say, our own architect colleagues as our own customers from the development department. We're making something that you as an architect should find giving you value when you're using this, when you're sketching. And the third one is sort of a little bit of hybrid. That's us, as you said, the extended arm, joining in for a short period on a project, focus on what we're good at, and then sort of pull out again when we've added that information, or we've trained some of the architects on that project to reuse whichever workflow we set up for them. So it's not necessarily like one thing or one workflow we look at. I mean, we sort of screen the project and see, is there anything in our toolbox that this project can benefit from? And we don't do it just because we can do it. It's only if it adds value to the project. Yeah. Coming back to our two main sectors, residential and hospital, there are tools out there, but for the residential or like prop tech, there's a lot of digital startups right now that can help you do good volume studies and focus on the areas and so on. But then you find out maybe they're not. I mean, our biggest market is in Norway, so maybe they can offer a quick daylight thing on the facades, but it's not really following the Norwegian rules. So what is it worth for us anyway? So we need to customize it and that's why we're making our own. And when it comes to the hospital market or the hospital projects, I think in Denmark there's relatively few organizations really having knowledge about this, and they are not really keen on sharing it. Finding algorithms to solve hospital logistics is not something you find on Google as you could find how to make a daylight simulation with Ladybug. Yeah. So we are compiling different experts' inputs in organization and putting that to the projects through software.
How can you elaborate perhaps this integration in the company and in the different teams in a form of knowledge sharing? Also, like not only thinking about has this unit contributed to attract more talent or get more exciting results or more interesting projects, but how do you get the designers to know what you're doing and what kind of initiatives you take for knowledge sharing? How do you elevate the office culture around what the work you guys do?
I think it's kind of ironic that most of the sort of focus we get in-house is through external communication. That we see that when other people are interested in this, our own colleagues also don't want to miss out on it. We do have different channels that we use in-house. Also, we have this influencer network. We have in-house webinars we're hosting. We have a SharePoint channel where we're sharing like small GIF animations is the fastest, easiest way to get an overview of how some tool is working. But I think a great impact is also having the LINK IO people and also in our influencer network sort of switch seats, sit next to someone. Because you will see, okay, on the screen something nice is happening over there, you come over, I'm usually doing this in 2 hours, how can you do it with one click? Let me show you. So the easiest way to sort of, because architects I wouldn't say by default, but many of them are very conservative. They don't want some external factors revolutionizing how you used to, make form out of your ideas, right? So that has to come from the inside. But if you can sort of inspire by showing how you do it next to them, then you're not forcing it on them. And I think that's quite important, because one thing we have looked on a lot lately is a program to handle all of our areas. So in Norway, Sweden, in Denmark we have Brutto and Netto. In Norway, Sweden, there's a lot of different ones. How do you sort of calculate that? Do you just take the Brutto times 0.9 or whichever you do when you're in early phase? Or do we sort of make some geometrical rules that we can visualize? And once we started doing that, the architect can sort of easily see on your building, okay, they offset, then they divide it or remove the core or something. And that allows them to sort of graphically quality check themselves, but also understand what's happening. It's a little more transparent than, let's say, the typical spreadsheet handling all of your areas. Yeah. And first time we show this tool to people, they are actually a little bit reluctant, because the spreadsheet works, why should I change it? But when you show on your own computer, here's version 1, here's version 2, what if I change the functionality of this thing? Okay, suddenly you would have 10 different spreadsheets, and here's just a toggle or whichever. So I think actually the biggest benefit is actually joining the teams and solving some of it on their project, and they can see how you do it, and then they want to reuse that next time. Yeah. And I think that's maybe the big difference also for having, let's say, an in-house computational designer compared to some external software developer that wants to sell you this. Now I'm also an entry point for a lot of software vendors who wants to sell new stuff to LINK, and they're actually very open, like saying, send us an example file, we'll do whichever simulation and so on and send it back to you. Yeah. But instead of black box, they don't show how you do it, because they're in beta or whatever. They have to spend 10 hours and then they say you spent 1 hour and here's the result. I have to see myself in that process. And that's where I think like computational designers, they join the architectural teams and they can see themselves in the process.
So you just mentioned something about being a gateway to software development, but now it reminds me a little bit about innovation, right? There's a lot of things you talked about, prop tech, tools coming to the market. I would like to shift the conversation a little bit towards innovation. There's a tendency that we overuse some words. We're going to come back to artificial intelligence in a little while, but words like sustainability, innovation, even last year, metaverse has been severely used and sometimes becomes very shallow, the meaning. So perhaps touching a little bit on the work you do and LINK.io. What is innovation, or what are architects really innovating these days? And if yes, where?
I think one of the hot topics, just to put another buzzword in there, is embodied carbon LCA calculations right now. And in Denmark, it's sort of been enforced by the regulations to do LCA calculations. And there was a lot of people like myself, I guess, in our competing companies around in the business here, saying, okay, here's a business opportunity. It's a rule in a few years. Let's make something that we can sell to the others, calculating this. So in a very short time, there came a lot of LCA tools, a lot of them coming from architectural firms, eventually together with engineering firms, because there was a business opportunity. And now we have, like, one of the old ones, which is not even Danish, but Tally. I think it's a Kieran Timberlake that made that. Ended up free or open source, but it was actually made as an in-house thing, then as a license thing, then it's free and open source. Free at least, I can't remember open source. But here in Denmark, we got LCA Collect, we got real-time LCA, we have Speckle LCA that we have been involved in, coming out in a very, very few years. And they sort of have to land, are we going for the same part of the design phase? One is more like a project leading thing, another one is more documentation and so on. And I think if we just sit down and wait for some software vendor to make all of this, I'm not sure that Autodesk 3 years ago would have said, oh, little Denmark got new rules in their building regulations, let's make a calculator for that. I mean, we pay them amounts that they should, but they are not. So sometimes, and I think in a lot of times actually, like, innovation comes, let's say, from the bottom, but it requires, the right frames to be in. And being allowed to, as a computational designer or as an architect in general, being able to just have a few unbillable hours experiment, because you see this can create potential on the next project and so on. That's where I think we are innovating. It starts small, but innovation is always, like a solution meeting at demand. And only the practitioners know the real demand. The software vendors don't. They maybe read it, but they don't understand how it is in reality and so on. Sometimes these developments get pushed later or migrates to a software vendor or a bigger concern because it got too big out of our hands. Maybe we don't have the budget to continue supporting or developing and so on. But the idea, I think, usually starts at the practitioner. A practitioner with the right mindset, like, there's some way we can do this smarter than we used to. Walter Isaacson, the guy who made the Steve Jobs and Einstein books, also has another one called The Innovators, which is like a biography for all of the people contributing to the development of the computer and the internet. And he shows that some of the first, pre-computers with punch cards and mechanical hard drives were actually made by, mathematicians and physicians who had some calculating task, but they wanted to, automate that. And it's a little bit the same thing we see, with computational designers being, normal architects, but they want to make a machine to make this thing smarter or better. So this was not coming from big, computer companies. They didn't exist. It came from people who had actually problems, everyday problems that they wanted to solve. And then later on, I think in the 60s, I forgot the guy's name, but he mentioned that the computer he made started as a paper and it ended up as a book, which was called, and I realized the other day, I read it like this part a week ago, he made the book, it was called something like Augmented Intelligence. And there's a phrase in there saying, like, he envisioned, and again, we're in 62. I mean, we didn't even have private computers till the 90s, right? So he envisioned that one day the computer would sort of augment. The architect would be sketching in an augmented environment. This is a guy who knows nothing about architecture and nothing about AI since the 60s. I was like, okay, he actually invented this thing.
Word.
That wasn't a side note. Yeah.
But that's actually great, because it does lead to the next question, which would be traditionally the practice has been very siloed, one could say. You have the designer is the architect, and the architect has a tradition, and it's following a certain pattern. The studios are growing within a certain pattern that it's recognizable pretty much across at least all Europe, which is not a very collaborative, interdisciplinary practice. So I would like to ask you a little bit about this topic, because as you just mentioned before, innovation comes from different mindsets coming together with ideas that are not within your typical realm, and suddenly sparkles that new thought. How do you see this interdisciplinary work? Is IO another discipline? Is the fact that you guys are a part of multi-consult meaning that you have a truly multidiscipline company? Can you elaborate a little bit on maybe the innovation part tied to the multidisciplinary collaboration?
For the last year, we've been developing on a toolbox, a more generalized toolbox we call Building Sketcher, and it's part of sort of a mindset we call the Augmented Architect. And the Augmented Architect was inspired a little bit by Tony Stark flying around in his Iron Man suit with heads-up display and so on. And we want to sort of, again, because no architect wants to be forced into taking decisions, we want to sort of make a software package that can nudge you taking the right decisions. So it's a little bit like in your car, if it says at this speed you're going more miles per gallon. We wanted to do the same thing with, areas and use out and LCA and so on. So every time you do a design change, you're aware of what are the changes. And I think in that sense, it's not so different from anyone else having a department or one person looking at parametric workflows. But what we really embraced is we coded an entire ecosystem from scratch. So we call them EP for early phase, and then we forgot to give it a better name. But then we have EP buildings, EP room, EP window, EP balcony, stuff we need in early phase. We don't have EP door handle. We don't have EP sink or something like that. It's only the stuff that's relevant when you're doing a volume study. So we kind of took the stuff we really liked from BIM, because BIM is disciplined, we can easily extract numbers and data. We wanted to take that and push it into Rhino in the volume study phase. So that requires some, let's say, backbone in software, saying what properties can we add to an EP building? Does it have nested rooms? How do I make a statistic of which rooms are compliant with daylight? But with code, that's much more easy, and it's much more easy to say, okay, here's a daylight calculation on this entire EP model. Which rule do I want to use? I want to use the Danish rules. Okay, here are the results. Then we switch. What if I put the same building in Sweden? Then it's different. They're looking at different metrics. And the same when we look at areas, again, coming back to we have Netto and Brutto, and there's so many different in the Scandinavian countries. So having a good backbone that's sort of a modular system, we can easily add to it. So when we wrote, let's say, the backbone, it was easy to add a daylight simulation module to it, because we had already defined what is a window, stuff we already know from BIM. And then if we have a volume study, it's just a box, for instance, we have methods to sort of generate floors, generate generic windows within some constraints, sill height or whatever. And then we can manually change a few windows, whatever, and then do a calculation of it. Are we still compliant? And we couldn't do that using, let's say, just a regular Ladybug workflow, for instance, because in Norway, the rules for the simplified rules for daylight is that your floor area cannot be more than, I think it's around 10%. It involves the light transmittance of the glass of your window area. if that window has a clear 45-degree shot to the sky without hitting any context. But then on top of that, you also have to add the area of the balcony above you to your own floor area. You can't do that if you don't have a disciplined model that knows this room is above this room and this is the connected balcony. If you did that in a plain daylight simulation, this would just be context. But it's not context, it's the balcony above. So we tried to make it as simple as possible, but still having the little amount of data that we need to do our early phase assessments. We are trying to integrate this, we have integrated this in our Rhino workflows. We have a standardized way of building volume studies that then can be read or translated into EP models. So as long as the architects sort of follow that discipline, it's not a lot of discipline because we tried to make all these geometric catches. If by some accident people did something, we'll try and fix it in the code. And once you have that model, we can do all of our simulations.
And all of these simulations, it's only on the architectural environment. There's no cross-discipline computation. You're not building tools for multi-consult or the more engineering disciplines.
So right now we are sort of helping them a little bit with the daylight stuff, because in multi-consult, let's say in an engineer's perspective, daylight lies sort of in two departments. One is the indoor climate and energy, and there's typically never any daylight experts. It's people's secondary skills, because I'm doing HVAC and stuff like that, but I also have to show compliance for regulation in daylight, or see how does my daylight affect my artificial lighting and put that into my energy model. And the other department that focuses on it is the actual lighting designers. And they have a much more, feel approach to it. And they might be the ones who can actually do, radiance simulation and stuff like that. And none of these people are or have the tools to really assess daylight in an early phase, because they used to assess this on the engineering MVP model that you get from the architect, or you recreate based on someone's BIM model much later. So they're not used to saying, okay, which KPIs can we look at in a volume study? Oh gosh, I'm an engineer, I'm not necessarily so good at modeling stuff in 3D. So I can hit run on this model, I can apply properties and stuff, but I'm not good at geometry. And I think talking to other computational designers out there also who are thriving a lot with geometry, that's really the key for them. Because I used to say to colleagues at Multiconsult, and I hope I don't offend anyone, but you're an engineer. Your prime values is finding out, do we want this structural system or this structural system? Or can we, if you're a good one, can we create some nice architecture out of picking this type of arch or something like that? But the amount of time you spend is maybe 40, maybe 80% on actually drawing that arch, not doing the calculation of it. So if we were with either computational design, translating the architect model to the engineering model, and ideally also getting the same feedback back, then the engineer could just add the properties and validate if it's making the model control rather than the model build up. And that's also what I've seen in Ladybug tools development. They have actually applied some kind of almost like GitHub, where you can branch different parts of your design. So you can branch out, okay, at December 1st, I'm checking out the architect model and I want to make some engineering calculations on it. And then you can merge them together and say, okay, here's the MVP pipes. So you can work in different versions and then merge them together. And when I've been proposing similar workflows in Denmark, now we're talking late phase, then people are very reluctant on real shared models. You can have your model and you can link my stuff into it, but there's a lot of, if things go wrong, who has the responsibility? So there's always sharp lines on who did what, who touched which part. And as long as we're doing that, we'll never get a real shared model, one model. It will be a collection of models, and we say this is our truth right now, but they are never 100% coordinated. Sorry to say. So do you think that's interesting? Yeah, the point of liability and shared models is a complex one, but I'm wondering if we could perhaps link this to the fact that the architecture, engineering, and the construction industry is
is quite slow to adopt some of the cutting edge technology. There's a lot of potential benefits that comes out of these new tools and systems and methods. But I mean, even in the case, if we pick up on BIM, which is nothing new, but has promised so much and under-delivered significantly because no one is really exploring the full potential of the methodology. You just talked a little bit about liability, responsibilities, who's touching which part of the model. What's your thoughts about the reluctancy of the industry to adapt to all this technology that it's out there and it's growing exponentially?
I think a good example to show, let's say, the reluctancy is, we're creating BIM models, but what we legally hand in is typically the drawings. Because there's a risk that there was some corner of the BIM model that is not present in any drawing, so no one has seen it, so no one has finally designed it. And if you sort of zoom to that corner and start building things after how it looked in the BIM model, the architect would say, but we didn't hand in any drawing showing this. And another example is, I've worked with a contractor who, he was not young, took his BIM model, printed all the drawings on A1, and had a red marker counting manually everything. Because his experiences, and probably there's some, let's say, bad image on BIM coming from the first generations of BIM. His experience is that, yeah, but we had a project where the floors were counted double or something like that. And I know it won't be when I'm printing every floor on a drawing and I'm measuring manually. I think that sort of trust in BIM is not completely there yet. And maybe it's just a matter of, waiting for the young guys who know everything about BIM, reaching his position, this guy who, what's it called, the estimator and so on. I don't know, but...
so it could be a generational
I think so.
issue. So younger designers might be early adopters of the technology and they're just waiting.
Yeah, but I mean, they're also prone to make errors. So, I mean, they don't have the same, experience of how do we quality check things. And like another example here in LINK right now, we are working on a huge development in Norway called Stranda. It's spanning like from Fisketorget here to the Sjællandsbroen. It's that big. Now we have used some of the EP toolbox to sort of control all of the areas of the plots and faces and all that. We are having a big round of how do we then quality check all of those numbers. And we're in dialogue, like what is the typical, COS or quality assurance methodology you use when you did it manually? I'm asking the architect, because I'll make sure you get the same documentation out of our tool and spit out a PDF page with a polyline of each floor or plot or whichever, put coordinates or numbers, or I'll give it to you and you can manually check if there's 50 buildings, there's also 50 pages or whichever. What sort of underlay do you use? And then we find out, in early phases, there are not so many standards for how you quality check. It's much more rigid, like what are we checking when we are printing from a BIM model than when we're doing a sketch project. So we're sort of inventing together with our quality assurance responsible in Norway, ways we can quality check our EP models and the outputs from them. Both in terms of what is the printed output, is some numbers, Excel, should we visualize data, should it be read if it's bigger than the normal, or should we visualize things in 3D, like areas, just being able to make a view, okay, now I'm checking areas, so everything's wireframe except the net areas, or something like that, just visualizing all that data. So maybe in our case, it's a Rhino model, but could also be BIM models. I've seen a lot of good examples of BIM models dragged into Power BI, and just, filtering in all that data. There's so much potential in that.
So let's shift gears now, go a little bit more into new fields.
Yes.
I know for a fact that you are a frequent participant of the hackathons here,
yes.
at Blocks Hub, and I would like to hear why do you feel that this is something that you want to contribute and spend a whole weekend trying to push forward for something new? Is it back to the innovation point? Is this because it's fun? What is the? I mean, I read you made a very funny comment about explaining what the hackathon is to some colleagues. It's a MIPIM for people that create stuff.
Yeah.
So tell us a little bit about Mathias, the hackathon attendee.
I mean, for me, joining a hackathon is a little bit like when you're a kid, you build stuff in Lego, right? I did. And the hackathon is where we all bring all of our Lego bricks and we put them together and see what can we build combined. It's about taking all that experience and sometimes small pieces of code you have already, combining it with everyone else and combining it with, people who stood there on the scene with real life problems. And it can feel a lot like doing work in a weekend. But the speed of it and because you're forced to, let's say, come with some kind of product or presentation in, let's say, 20 hours of work, allows you to also do a lot of quick and dirty solutions and skip the boring stuff and just try to make a lot of impact in very short time. And I think it's incredible how much you get out of such short time. It's never like finished software or anything like that, but just sharing visions or showing prototypes of this could be a thing if we had 2 more weeks or 2 more years. And then it's always a good network opportunity because, there's all of the computational designers in the other Copenhagen architect studios, in the engineering firms, and even a lot of the BIM controllers or model controllers. They have the same sort of development mindset, and you meet these people and you find out, like, one thing is we do sort of the same thing at work, but we also find out we read the same books and we see the same films. So it's fun, it's social, and yeah.
So there was, in this latest hackathon, that of course there was a lot of focus on artificial intelligence. So maybe to start wrapping up the conversation today, how would you envision the integration of artificial intelligence tools into the practice? Is this something that you actively have been looking into? Any thoughts on the latest developments?
We have a PhD student right now, Paul Philip, and he's looking into point clouds image segmentation for scans of buildings. So he's actually soon leaving for the university in Aachen, where apparently you find all of the experts in this field. He is geeking all out on neural networks and stuff I don't understand anything about. So we do have some people, or one person with the very, let's say, hardcore skills in this. If we zoom out a little bit, we are using Stable Diffusion now to do visualizations. We are experimenting also with a lot of help from Paul on how to, using what's called control net to lock parts of your visualization and then let the AI guess new stuff. So with the control net, if you have a good workflow for doing that, you can sort of show, here's 3 different renders. Which style do you like the most? Okay, this one. Okay. Next one is, what about the background? So we lock the style. Now we're just varying background. Now we're varying facade expressions and so on. And it becomes sort of a design process, a dialogue you have with your AI being sort of a sketching tool for you. And that works really well on images because there's so much trained data. It's trained on all the Google images and so on. So it's fairly robust. I think if you wanted to brainstorm on a MEP system, there might not be as much training data out now. So you couldn't just download a pre-trained model and apply. In terms of low-hanging fruits, I see a lot with ChatGPT integration right now, API access and so on, and the same with Stable Diffusion. Those are low-hanging fruits. Other people have spent hundreds of millions of dollars training these models, and you can download them and apply them. Maybe you can tweak them, maybe you can put an overlay on top of it, or add some pre-prompts or whichever that gives you the style you're looking for. Then you can just experiment. You don't have to know anything about AI at all. And then there's some more, let's say, local solutions where you actually have some of your own data, you start training on it. And I remember we had a chat 5 years ago at Henning Larsen where we were cleaning up the archives, and we had drawings back from the 60s, printed or hand-drawn A1 drawings. And we wanted to see, is there any way we can sort of digitize them, let's say in a smarter way than just scanning the PDFs and get rid of the paper. We had a lot of good ideas of doing that and combining that with, the current BIM models, and then show, trend curves of, are we getting more toilets per user in a building or something like that. It didn't really turn out to be any project, but we actually applied for some funding on that. But then you see, for instance, now there's a company called Creo or something like that, and they can do takeoffs of DWGs and PDFs, for instance. So it can recognize what is a wall, what is a door, and so on. So you just mark your PDF and it says, here's 12 doors. That's incredibly smart, because if you kept your old drawings from the 60s, you suddenly have a lot of data you can reuse. But what should you use it for? One example is also back at Henning Larsen, we had a primary school architect who specialized in designing new primary schools. And she had, 20 years of experience in this. And over 20 years, you're only involved in, let's say, 6 build projects. If you're involved in all of the phases, so you might have the experience of 6 projects, and then maybe a little bit touch down on other projects happening. But let's say the studio, or maybe other like physical offices, but in the same organization, had worked on 20, 50 projects in that time. And still the prime expert in this has only been working on 6 out of 50. And I think AI or machine learning would be the key, and it's actually just statistics, one can say, but would be the key to get knowledge from the Norwegian schools, the Danish schools, and everything. So we would have, let's say, a digital primary school expert on at least the measurable part. So we know how big should a wardrobe be and all that stuff. Funny thing is this architect, she actually left at Henning Larsen. So suddenly you don't have the primary school expert anymore. So if you invested in putting that into some kind of model in some language that the users can understand, I don't know if it's through code or through images, but there must be some interface that we can explain to the model what was my data, but also we can prompt and ask the model what do I need to know about this data.
Yeah. What about, we're almost at the end, but just would like to ask you, what's your opinion on education? So young professionals that are coming to the marketplace, but also those that are still in school, perhaps just started their education, and they will come out in a market that is evolving quite fast. What would be your top 3 recommendations to keep focus on from what we can judge today?
Yeah, sure. I think it's important that you get a very general, broad understanding of this field, because architecture, I sometimes joke that engineering is knowledge, architecture is culture, but architecture is, there's so many, rules, regulations, phases, stakeholders, building products. There's no one knowing all of the, there doesn't exist one person who knows all of the just facade elements you can get. It's so broad that I think we should just embrace having let's say a shallow understanding of everything, being very generalized. I think the schools should offer that. And then, of course, a critical thinking and a creative mindset and all of that we have in the architecture schools now. In terms of the more, let's say, digital competences, I think it's important that we get sort of a general knowledge, but I would also be afraid of going too deep with it, because not every architect needs to be a BIM specialist. And the ones who think it's funny to work more than just sketching in BIM, but doing fancy stuff in BIM programs, they will more or less learn in themselves. If you point them to an online resource or something like that, you can't stop learning. And it's the same whether it's daylight, whether it's timber buildings or whichever. Just provide the resources. You don't have to teach everyone expert in everything, because this field, I'm repeating myself here, but the field is just so large that after 30 years you wouldn't know half of it still. So just making a palette of, here's all the stuff you can dive into in your spare time or do a specialized semester about. I don't think that you should spend too much time having a mediocre Python teacher at a architecture school or construction architect school. Or maybe you do that as an introduction, but there's so many good courses out there, like with millions of users, 5 stars from everyone. Like, they are so well prepared, some of those online courses, that just accept that they are better than you and then outsource some of the teaching, I think, for these very hardcore things, and focus on the interplay between all of the disciplines.
Yeah, absolutely. We talk a lot about this topic of education, the future of education, the impact implications. Yeah. So we're not going to open that box right now, because it will be another conversation. But one last question to you. It's the crystal ball question. Try to visualize the profession in 10 years' time.
that is
what happened?
That is
what
so
happened?
dangerous, because if you ask me 1 year ago, it would be completely different, right?
I'll ask you again in 1 year time.
Yeah, and you'll show me what we talked about today. I think there will be a shift in some of the expert knowledge. If you read, I think it's called Susskind and Susskind, The Future of Professions, they're talking about you're taking all of the professions, and then you take the AI, and maybe you rank all of the professions on how difficult they are to learn, and the AI will sort of slowly mitigate that, or automation in some way, right? And then typically, maybe in the top, maybe not necessarily in the top, but we have a lot of, monopolized professions. You're certified something and so on. I see a lot of the stuff that these professions with monopoly to exercise, whatever it is. Yeah, I think this, let's say, hybrid interface using AI, doing your profession, will definitely give you superpowers. That will be the augmented lawyer, the augmented architect, the augmented so on. And I think the skills needed to be that augmented architect, it will require less and less of you to communicate with that AI or whichever it is, because even if it's not a real AI you want to communicate with, let's say it's a building energy simulation program, maybe the AI will be the translator. The AI will be the interface. I ask, what should I do if I have too heated rooms here, too much overheat in these rooms? And it will suggest, because it had played with a lot of previous models and so on. 2 years ago, I spent a lot of time diving into CNNs, convolutional neural networks, which is some of the base behind stable diffusion and so on. And I think, oh wow, with discrete diffusion, we could make some cool images and so on, but it requires some parameter tweaking, and I spent some weekends being good at that. And then, a month later came Midjourney. It's just a chatbot. You ask for a beautiful image of whichever, and you say what scene you want. And I was like, with manual, all right, I can maybe do that better. And then came generation 3 and 4, and now we're like, okay, it's picture perfect. And looking at retro perspective, did I then waste those 2 weekends learning discrete diffusion? And I think we'll have that feeling with more and more stuff, like reading up on something, like becoming good at some calculation or software. You'll find out in half a year. If there's a big enough demand on it globally, there'll be someone made a model that can do it for you. And maybe that then could sort of lead us to, do we need to do it locally instead? And that's why I think, like, these large language models, for instance, like ChatGPT, there's been examples of them being better at doing chemistry formulas than actual trained chemistry models. You can find that in the AI Dilemma, really good talk on YouTube. And that just shows, like, chemistry guys, did they waste a few years making their own model, and then comes a generalized one that read and passed YouTube videos in different languages and so on? Is it wasteful work then? And it's always like a race. And I think there's always like a trade-off. If you want to be the first one doing something, it costs 10 times as much as being the second one, and so on. And you might only, when it comes to AI, you might only be the first one for a day or two. It feels like that. Paul, Philip, our PhD student, he just had a supervisor meeting in Aachen, and he showed his entire pipeline for images, segmentations, what are all the modules to come to a conclusion of which parts can be reused of this building. And the supervisor said, okay, this module is a PhD, this module is a PhD, and so on. And he said, if you focus on one of them, you have to be finished with that box or that model in 3 months. Otherwise it's too late. Otherwise it's not relevant anymore. Someone else will do it. So these small sprints, actually comparing, let's say, the development happening in AI with the development happening in computational design. In AI, most of the papers in academia, now there's not so many anymore, it's mostly in the big commercial firms, but most of the papers submitted, including the code, it's all transparent, so others can base on top of it or tweak it or use it in commercial, because they just want to contribute to this big pool of knowledge. Whereas we see also in computational design, I mean, someone made a Dynamo script to count the number of doors, and then they show off on LinkedIn, and then day after someone else made another door counting scheme and you show off on that, and then we say we're all innovating. I don't know if we are, but in that sense, there's at least 5 different parking lot scripts out there in my LinkedIn feed doing exactly the same thing, and 2 of them are open source, so I don't know what the others invented afterwards. But yeah, and on top of this general knowledge, it's also about, you know, getting hands-on, being part of the actual design process, and in that sense, internships are really important. And we are always looking for good interns, and both, you know, construction architects, but also, let's say, the more nerdy mindsets. In that sense, I think just having the right mindset is a big deal, because you can always, you know, learn Python or something like that if you have the right mindset. So you don't have to know everything beforehand. Yeah.
And it's internships for LINK Arkitektur or for LINK IO?
Actually, in both, but in IO we are always open for interns who want to sort of contribute or use our code base, and also people who want to just use this as architects and show the senior architects how you can do stuff. And those are our Trojan horses, right?
Yeah, great. Well, Mathias, it was a pleasure to have you. It was fascinating.
Likewise.
So let's see if in 1 year we need to catch up again.
Don't show me what I just said in 1 year.
Thank you so much. We'll see you in the next episode. Thank you.
Thank you.